Okay, so right now we are going to study about the preparation of diazonium salt. Now it's better to write it this way rather than writing what is written in the book. So I'm going to show you. So it occurs in two steps. Step 1 is the production of diazonium ion. What's going to happen is we're going to take an amine with an R group and we're going to combine it with HNO2. Now this HNO2 can also be written as ONOH. Now why am I doing that is because I'm going to combine these and make water out of it, and then I'm going to attach this with a triple bond and I'm going to leave hydroxyl as a byproduct. Now nitrogen is utilizing its lone pair also, so I'm going to put a positive charge over here. Now this the conditions of this reaction is actually that it follows NaNO2 HCl, and it occurs at 0 to 5 degrees Celsius because above this temperature it breaks down. The diazonium ion is what I'm talking about. It breaks down. So this is the diazonium ion formed, and then this diazonium ion is going to further react with HCl and water, or let's just say it reacts with OH negative to form, let me write the conditions, NaNO2 and HCl 0 to 5 degrees Celsius. So what's going to happen is it's going to make that bond with chlorine minus, and then it's going, the H and OH is going to combine and form H2O. So that's that. And now if we add these both reactions, we see that the H2O adds up, but the OH minus cancels out. This also cancels out, diazonium ion also cancels out, and there's nothing more to cancel out. So we will write that reaction as follows, or we could just write it as HNO2 plus HCl. The conditions are NaNO2 plus HCl at 0 to 5 degrees Celsius. It's going to form a diazonium salt and 2 moles of water. And this is the reaction that is present in the book itself. Now if we ask for a reaction of diazonium salt, it will be as follows. Now we know that above 10 degrees Celsius the diazonium salt breaks down. So let's just say we have this salt right here. What we're going to do is we're going to raise the temperature to 10 degrees Celsius. It's going to break down into nitrogen gas and it's going to leave us with this body over here. Now this can, the ethyl can combine with OH minus and give us an alcohol, which is ethanol, and it can in and of itself delocalize its positive charge, and it can actually undergo hyperconjugation and form a double bond over here and remove this H, so it will form an ethene. Now one thing to note is that we can also, so what we have over here is a benzene ring, so we can also represent it as this. This is going to react the same way. It's going to react with HNO2, so the same thing is going to happen over here as well. And NO2 to HCl 0 to 5 degrees Celsius, the same conditions met, then we will have something called as a benzene diazonium ion. If we see here, as before, the reaction will be, byproducts will be H2O and H-. Same goes for here, C6H5 and triple bond N positive, the same byproducts. Now the reason I've written it like this is because if we see this over here, that the positive charge is delocalized over the entire ring, meaning conjugation is occurring also. And then, so that would mean that aryl diazonium ion is more stable than another, like an alkyl diazonium ion. So this conclusion is important in MCQ point of view, and these two reactions are actually really simple, so anything could come from the organic part, so we've got to prepare it.